In section 7.1, general differential equations. So in general, a differential equation is an equation that contains an unknown function and one or more of its derivatives. The order of a differential equation is the order of the highest derivative that occurs in the equation. Thus, equations 1 and 2 are first order equations, and equation 3 is a second order equation. In all three of those equations, the independent variable is called t and represents time. But in general, the independent variable doesn't have to represent time. So for example, when we consider a differential equation y prime is equal to xy, it is understood that y is an unknown function of x. Now a function f is called a solution of a differential equation if the equation is satisfied when y is equal to f of x and its derivatives are substituted into the equation. Thus f is a solution of equation 4 if f prime of x is equal to x times f of x for all values of x in some interval. When we are asked to solve a differential equation, we are expected to find all possible solutions of the equation. We have already solved some particularly simple differential equations, namely those of the form y prime is equal to f of x. So for instance, we know that the general solution of the differential equation y prime equals x cubed is given by y is equal to x to the fourth over 4 plus c, where c is an arbitrary constant. But in general, solving a differential equation is not an easy matter. There is no systematic technique that enables us to solve all differential equations. In section 7.2, however, we will see how to draw rough graphs of solutions even when we have no explicit formula. We will also learn how to find numerical approximations to solutions.